right, I believe we are already live, but just seeing here. Yeah. Wonderful. Cool. Welcome, everybody. Just sit tight. We're going to get started soon here. Yeah. Just doing a little quick test over here. Okay. Okay. All right. This is cool. Very, very exciting to see. Welcome, everyone. This is our first foray into our new partnership with Spectre Academy, as you can see over here on the screen. So thank you for joining us today. My name is Ken Candelas, as many of you guys know. Let's just go to here for a second. I am your host and your instructor for today. Now, today is actually kind of a special day because we're not doing things as we used to do them on Metal Mastermind, okay? Now that we are a partner of Spectre Academy, what we're going to be doing is hosting live streams every week. And now this first one is actually kind of special only because it's our first one. So we're actually opening the doors to everybody to see what this is all about. And you guys can ask me questions in the chat. I'm going to be talking a little bit about Spectre Academy today, as well as its first lesson. Now, the way this works is that Spectre and Metal Mastermind, we've joined forces. We've brought our teams together in order to create this service for you. And in the future, if you're interested in doing more of these services, let me go back to my screen share over here. This is the All Access Pass with Spectre Academy. What you're getting today is a freebie, but in the future, this will be an exclusive thing only for members that are on Spectre Academy All Access Pass. So the way if you want to get a part of this is very easy. We have an entire sign up located here. You can just go ahead and click Learn More. And basically, you have a couple of different options as to what that looks like for you. So whether or not you like, maybe only signing up for a month, or if you want to sign up for a quarter, or if you want to sign up for a whole year. There are varying reasons to choose those. You'll see that we have a couple of differences between Spectre Academy and some of our competitors, especially the university space, which is, of course, where some of you know that I actually do teach. I do teach in several universities here in the city of New York, and most namely some of the biggest places in New York, in CUNY and SAE included. And these are fantastic resources, but I know that a lot of students especially that come into universities, they always have a real issue with what's happening to them in the future, which is, all the debt and all that stuff, especially here in the United States. We don't really have that great of a support system for education. I'll be the first to say that. But when we're talking about doing something like this with Spectre Academy is doing something amazing with Metal Mastermind, because everything that we're putting together here is meant to help revolutionize the education system, okay? We're trying to take it into our own hands, trying to offer you guys an opportunity to really get the best of both worlds of learning online and also having structure, because those are the things that going on YouTube University, let's just put it that way. YouTube University isn't going to give you the structure that you need. It might have the information, but you're going to have to dig for it. You're going to have to put it together, and then you don't even know what order you should even learn things in. So that's what this is, right? So Spectre Academy is going to give you access to a lot of things, including education discounts, which we've made partnerships. Even as Metal Mastermind, we've already done this, but now we've included with Spectre Academy a couple of really, really amazing stuff, Isotope, and all that kind of stuff included. So you're going to see all this. We have all these instructors that are going to be available to be doing live streams just like this. And you can see my friendly face over there, yoo-hoo, right? But we're going to have a whole bunch of, these are not the only instructors. These are only a couple of the people. Every course that is on Spectre Academy and their instructors will have access to doing live streams. So if you want to learn directly from us, and if you're a part of YouTube University, so to speak, you could learn directly from the YouTubers who are actually teaching this stuff. And, in terms of guys like we're going to be coming at it from another angle. We've got, some educational experience. We've got some professional experience, and all that combined along with this online platform, I think is going to be really, really exciting. So, it actually only starts at $1 just for you to get through the door for this month. This is our trial, guarantee. And as you kind of go through this, you can sort of like pick and choose what courses you want to learn from. You can learn at your own pace. And of course, you have access to these live streams, which we're conducting right now, which to me, honestly, is the biggest value, right? Getting one-on-one, interaction with the person that you're doing. And, in the future, we're actually setting up things like coaching calls so that you could literally have just a one-on-one with that person. So this is something that we're really, really excited about. Shout out to all these people and all of our students who have already started taking All Access Pass. We're very excited. But yes, this is our first stream. So give it up. This is great. I'm really, really excited. Again, my name is Ken Candelas. I am an instructor here at Spectre Academy, and of course, I am the CEO of Metal Mastermind, its partner. So that's about for what we have here with the launch of Spectre Academy. If you have any questions about that, please feel free to put it in the chat section and all that. And without further ado, let me also start recording. And right over here, we're going to get started with our first lesson so that you guys have access to this. Let's go ahead and just start pulling some of that up right now. Now, for those of you who don't know, I am a audio educator, okay? So a lot of what I do on a day-to-day basis is really just teaching audio to students all over New York City, and likewise, of course, around the world. So audio education is something I'm really, really passionate about, and it's definitely something that I know that you guys are also passionate about. And so while we go through this, I just want you to be aware, this is usually kind of where I have my expertise. It's talking about audio. Also, of course, music education is very important to me as well. I definitely will be doing some music-related stuff in the future. But these are all kind of full circle things. At least I think so. I think they're full circle. Because when we start really getting into stuff like audio, it usually is always tied to music in some way, shape, or form. Okay, so all right, let's get started. So the sound fundamentals. Now we've got definitely a couple of different, how would you call it? We got a couple of different things that we can talk about here. But I figured just for the first one, let's just keep it nice and simple. Let's talk about an introduction to sound and what that even means. So let's talk about the theory of waves. And really, it truly is, in some ways, a theory. Because a theory needs to be, of course, what's going on over here? Yeah, try it now. Yeah, okay. Just X this out. I don't need to edit my own PDF at this point. The theory of waves, what is a theory, right? It's really just a person An idea that is a conceptual thing that we can, again, here I have another pop-up, a conceptual thing that we're trying to prove, right? A hypothesis, a conclusion, and all these sorts of things. An abstract, right? Theories are very important, but they also help us to explain the physical world. And when it comes to doing something like sound, which absolutely deals with physics, is a really, really vital part of how we understand and operate with the music industry. So if we actually truly understand sound on a fundamental level, you're going to see that this actually pays off dividends for you in so many other ways than just, learning how to mic up a guitar amp. Okay? It really comes down, and, if you really ask me, this is part of what unlocks the secrets to mastery in all of this. Okay, really, and it's hard. It's an arduous process to go through and learn all this stuff. Believe me, it is not easy. However, it rewards you with freedom. Okay, so let's start with the first thing. I like to typically start my conversations talking about a very special person. Let me just put this a little bit down over here so that you can actually see my screen there. Okay, so a person by the name of, Isaac Newton. Okay, so Isaac Newton is someone who's really key in all of this, mainly because Isaac he discovered, not really discovered, everybody knew about kind of like gravity, but they didn't understand how gravity worked, right? Now, why are we talking about gravity in the face of sound? Well, because in order for us to have sound, we need to live in an environment that sound can exist in. And part of that is an excursion of force, okay? So when we talk about Isaac Newton, the reason why we do this is because Isaac figured out how to calculate force. And this is something that in the basic fundamentals of all that we understand with sound, it's a property of it, okay? So the law of inertia, the law of forces, and the third law, which we'll get to in a second, these are integral to understand. And sometimes it might even be a little bit more of a meditative kind of thing if you think about it, right? So like the law of inertia, where material objects in our universe resist change, okay? And I'm not talking about resisting change like wanting to eat Cheetos at your desk all day and not wanting to do work, although that is some sort of a resistance to change, but not in this case. We're talking about the resistance to change in motion, okay? So when you send something out, for example, into space, and it doesn't stop moving, it is still very inert, right? Only because it is not being obstructed by something else, right? So inertia is a very important part of movement, right? One of the parts of that we have, let's say, for example, one of the reasons why we don't have something like really, fast cars that go beyond 770 miles per hour, like let's say Mach 1, right? It's so hard to get to Mach 1. And the reason for that is because we have friction, and not just because of friction in our tires hitting the road, which absolutely creates friction, but even in air, right? The actual molecules of air that we don't see, but we feel, right? That's why we have wind, right? So it is still a physical force of molecules that are kind of just like blocking our ability to move. And this is where we are talking about resistance to change. So in an environment for sound, we also see this, right? And how we overcome, let's talk about live sound. If we're in an audience of people, let's say Global Citizen Festival at Central Park, right? Where we get a lot of people who come in from all over the city or all over the world, and they want to go ahead and see this big giant music festival. Well, how do you do sound for that? Well, you got to overcome the environment, and part of that could be a windy day, it could be humidity, all this kind of stuff is a resistance to the information that comes out through the speakers, Okay? We also have the law of forces in this case, which is the amount of matter or mass, we call that, right? If you get a lot of matter put together, right, we create a lot of mass, which creates a lot of weight. Okay? And then we also have the change in motion, which we accentuate with something called acceleration. Okay? Now, acceleration just means a change in speed over time. Okay? And putting these two together with contact forces and field forces, so something like physical touch, which, you know, we can absolutely feel. Think about like a subwoofer, right? Pushing out sound in a way that allows you to absolutely feel it. Or we can talk about, you know, magnetism or electricity. Those are other ways of forces, right? So if we're talking about, you know, electrical cables and power cables even, or audio signal cables, right? There is a change dependent on the kind of amount of electricity and the purity of that electricity that's even able to go through. And we'll talk about that later in our live streams. So now this force, it's sort of a push and pull that's equal to the mass of the object that's multiplied by the acceleration. So now what you can think of this is like, you know, a speaker cone, right? It's going in and out, right? Well, how fast can that go in and out? That is a really good question because, you know, if we're talking about the precision of, let's say, a subwoofer, how much information that goes back and forth, pushing all this air, right? In and out, in and out, in and out. It's pushing all this air. How tight can it retain control over that movement? Because at the same token, as it's doing this in and out motion, you're also receiving information from the speaker itself back into the amplifier. We call that feedback. All right. Very similar to the same kind of feedback that when you put out sound in live sound and then you pick that up from the microphone and it comes right back out of the same speakers, right? And you hear that whoop, right? That kind of feedback is the same information we're talking about, okay? Except that it's all internally put in from the speaker cone itself back to its own amplifier. Okay, because here's the thing about, you know, electricity, which is very interesting, right? Because in order to create a speaker cone to move, right, we supply with an electrical current. That electrical current flips over the that electrical current flips over the magnetism that's inside the coil. Okay, so that coil of wire is going to be changing from north to south as we have the electrical current go positive and negative, right? Depending on the signal of the wave, right? So as that's happening, information that's going to the cone, well, guess what? That cone going back and forth is also creating an electrical current that goes back down the line, okay? So this is quite literally a literal physical limitation of speaker technology that, you know, speaker designers have been trying to overcome for many, many years. And, you know, we have different types of technology like servo subwoofers and, you know, even like some of the newer ones, like you'll find like Genelec got these amazing speakers called the Ones, which are like all these point source coaxial type speakers. They're amazing to listen to. And a lot of the amplifier technology has been developed greatly by this kind of knowledge. Okay. So the speed and direction of where things are pushing and pulling and how that affects physical and forces, field forces, they're all related, okay? I'm telling you. So learning some of this stuff is even on a fundamental level like this is really, really, it drives me, you know, it is what keeps me up at night. So, but again, so now all this stuff, by the way, guys, just to keep you, you know, in the loop, right? If you're coming in just now, the All Access Pass from Spectre Academy has this information, okay, in one of my own courses. Some of you may have even taken this. This is Metal Studio Designer, where I go over this kind of stuff, okay? So if you want to see all this stuff in a pre-recorded, you know, fashion, where I break down all this stuff as I'm doing it to you today, but on your own time to be able to watch all of this in detail, it's in the course, right? But I'm just doing this here just to give to you guys as a little bit of an introduction, okay? So let's take a look at this, right? So the third one, which when I come back to the whole idea of this even being part of a meditative thing, because it's almost philosophical. I mean, I am one for all this philosophical stuff, because at the same token, like looking at this from a physics point, and then also looking at this for every force in action, there's an equal and opposite force reaction. I mean, like you could probably just call that karma, right? So this is quite literally so directly correlated to things that we actually do in life, which is kind of hilarious. So this is interesting. So in essence, things that we do in the real world happen because there is also a reaction to that, right? So whether you're the proactive force or you're the reactive force, the truth is still the same. You always respond. It's like, well, when your mom tells you you got to do this, and you respond with, I don't want to do that. I'm going to do this instead, right? That rebellious attitude, right? All that. This is all forces and, positive and negative reactions, okay? It's the counterbalance of life. It really is the yin yang, right? So in physics, when we talk about force, take a look at this equation over here. So the N stands for the Newton, okay? And that's how we've kind of given the name of the unit is through, of course, Isaac Newton. So what does this mean? It says kilograms, and then you've got, the parentheses, meters over, S, which is seconds square. What does that all mean? So in this case, the way I look at an equation like this, when you see kilograms, right, it just means weight, right? So how much weight you attribute, right, because it's multiplied by meters per second. So we're talking about over the course of how far it's going, right, multiplied by the weight, and that per second is a really important part because it has a square to it. So at any time you see a squared, it means we're working with an exponential factor, right? Now think about it, right? Even if you were to just jolt your hand, like to go really fast, like if you're trying to, let's say, be Bruce Lee for a quick moment, you want to be really fast and try to do his same karate chops, right? And I know Bruce Lee probably didn't even do karate. It was like Wing Chun and all that stuff. But let's just say, right? So you're trying to do all the things that Bruce Lee's doing, but it's going to take a moment for you to like get into position and then do the action, right? So acceleration happens over time, which is a really, really key factor. It's not a static thing, okay? That's why we don't just say speed is, in this case, static. It's acceleration. It requires that depending on how fast you do it, the weight that you attribute to it creates force. Does that make sense? Okay? So this is really, really, really cool. And again, going back to the idea of that speaker cone, I mean, like how fast is it going to actually put out the information versus how fast it's going to restrict the information and stop that speaker from vibrating more, right? That's what we call really tight, bass, or for example, with a sub. Or you get immense clarity with that kind of stuff. So, a lot of speaker design, if you really think about it, a lot of speaker design has inherently its own flaws because it has to overcome a very physical limitation. It might have. This is, by the way, guys, let me just go to the main screen here. Because when you're thinking about buying something like a speaker driver, okay, it's not just about frequency response. And this is why, you can have like a frequency response that's relatively flat and still not necessarily enjoy what you're listening to or, appreciate the kind of, clarity or lack of clarity. Therefore, I mean, they could have very similar frequency responses, but the sound will be totally different, right? That is because frequency response isn't the only thing that you think about, right? It's also like transient definition. Transient definition happens in a very short amount of time, not long periods of time. Okay, it's kind of like a relationship between like peak versus RMS, if you're familiar with that concept. Okay, so the body of the signal versus the very outer edges of the signal, right? Those are two different measurements. So speaker design is very, very similar in that regard. So when you're deciding to, purchase a speaker, that's why they say you have to really listen to it. You have to listen to it in your environment. Even better is the best place to do it, so that you could actually hear what it's doing in your space. Because that's another part to all of this that, you're getting into sound, right? Your space is its own profile, its own signature. And when you don't have a space that is treated to be able to do these sorts of things, those kinds of minute details will always be elusive to you, right? Okay. Let's get back to the presentation. Okay, so now what we're looking at over here is essentially our, deliberation on what do we use to measure sound. And most of the time, not all times, but most of the time, it's metric. Now, for those of us in the Americas, okay, we got to get a little comfortable with this, only because so much is actually factored in meters. Now, it's funny because the rest of the world actually is doing this for us as a courtesy that we still work with the imperial system. However, you still look at things like kilohertz and all that stuff, and that's all metric, okay? So kilohertz and sound frequencies, we're using the system because it is much easier to do exponential factors in this realm. Okay, so logarithms and all that kind of stuff, they work a lot easier in the metric system. Okay, so we add scientific notation, which of course adds, to the exponent, and we can put all that information into a calculator, and it's just simpler. Okay, this is where we get our stuff from. So now you can even see on the left side of that chart where it has our prefix, things like kilo, mega, giga, tera, peta, exa, etc. Those are the ways that we describe how big of a number we're working with. Okay, so it's good for us to be able to be familiar with this stuff. So because, for example, like electrons, and if we're measuring electrons, those are on picometers. Very, 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 very small, right? And then when we're talking about, delay, usually we talk in milliseconds, right? So these kinds of things are very relevant to us. So just because it's metric that we're talking about here doesn't mean it doesn't apply to you if you're in the US, okay? It very much does. And we still, like I said, we still use the imperial for many things, okay? Let's go and let's move my, nope, that's my main screen. I don't want to do that. I want to move the little guy here. Just put this up here. This might be a little bit of a better spot. All right. So as we are talking about sound, let's actually define it for a quick moment, because this is a very good place to be able to actually just talk about what sound is, okay? Sound can be in any form. Let me say that again. Sound can be in any form within an environment that has tangible access. Okay? So what do I mean? I mean that sound can exist in water, sound can exist in a gas, sound can exist in normal air and oxygen. The reason why we just take sound for granted is because we quite literally live on Earth. I'm not even kidding, right? We don't even think about sound because it is that embedded into our psyche, right? Because if we are in our environment here on Earth on a constant basis, which of course we are, otherwise, we wouldn't exist anymore, then we're not really aware of, well, we take it for granted, essentially, right? If we were to be out in space, there would be no sound because there is no molecule to transfer from one molecule to the other. Or, there is in space. There definitely is. But it's so far apart, those molecules have a really hard time reaching other molecules. So we have inertia, another form of, in this case, resistance, because there is barely any room or barely any molecules within a close proximity to be able to transfer energy. Okay, and if you only have a little bit of energy that can be transferred, then it's not going to go very far because you need an enormous amount of power in order to do that. Okay, so baryonic matter Baryonic matter is every kind of matter in the universe, okay, that's tangible, that we can actually interact with, whether it's electrical, whether it's magnetism, or these are forces in a way, but electrons, right? Electrons are actually physical. But, you can talk about that. You can talk about, carbon. You can talk about anything, right? Our skin. These are all baryonic matter, okay? And acoustic waves are periodic disturbances of molecules that are these vibrations transmitted through this medium. Okay, this baryonic matter, okay? And depending on the environment that it's in, it changes, okay? So everywhere on Earth that we are experiencing, sound, you're going to be able to actually have a slightly different experience where you go, right? If you're going to do a studio that's in the top of the Himalayas, you're going to have a different atmospheric pressure than you are going to have here on sea level. Okay? So, yeah, could that affect the quality of your mix? Maybe. It all depends on how familiar you are with it. I can tell you, though, that coming into a different pressurized room will definitely make you feel like things have slightly changed. Okay? So, the question is your awareness, right? How aware are you of the changes that are being made? Okay, so in this case, right, periodic disturbance of molecules in an elastic medium, and it has to be elastic. Okay, can't be if you're in a solid, right? Obviously, nobody can exist inside a metal plate, right? We have to be able to walk through the metal to be really able to experience it, right? Now, in this case too, you could touch metal and feel the vibration, right? But at the end of the day, that vibration will then exist in another form, right? So if it's pushing through a metallic vibration, that vibration then echoes within air. And then you're hearing a resonance come from, let's say, like a metal tube, for example, right? So everything still has this sort of medium that it travels through. And that's one of the key things about acoustic design, right? Is how do you stop? Because this is the question. How do you stop sound and vibrations from penetrating and bleeding into other places where they're not supposed to be in? Right? That's the difference about going to a commercial studio rather than, doing stuff in your bedroom, right? Because if you go to a commercial studio and you play drums, those drums, they're not going to go to another, floor in a commercial building. They've acoustically isolated the drums, or as best as they can in many cases, right? Not everything can always be built perfectly. But at the same token, when you're doing it at home, right, you might not have that same luxury, and now you're going to have to deal with your neighbors, filing noise complaints. Okay? And this is all within the power of, acoustic isolation. So even though it's like we're talking about sound as a very basic fundamental force here, right? This knowledge goes really everywhere in our production skills. Okay, so let's keep going. So put it more simply, sound is created by a force which causes a push and a pull motion of these molecules, which then propagates. Okay, or it moves through the environment in the form of kinetic energy, okay? Now that kinetic energy is very, very vital here, okay? Because that kinetic energy is motion, transfer of motion, right? Physically from one, think of a, Newton's cradle, for example, right? You got that thing that goes back and forth and it just keeps moving the ball left and right, as it keeps connecting. It's exactly that. It's that force that transmits and then it bridges to the other side, it comes back, and it moves around, right? So again, this is that positive and negative force that we've been talking about. Okay, now, so in order for sound to be experienced, we need to have the presence of matter. I explained this. Cannot exist in a space like vacuum. Okay, vacuums are devoid of any substance, contrary to experiences we have with Hollywood movies. I'm sure some of you have probably seen Star Trek or Star Wars, and you hear all the within space, and it's like, no, that does not happen. It does not happen in real life. It would just be a real silent spaceship, and then all of a sudden your ship explodes and you have no idea what happened. That's what would really happen. So in Earth, however, we have a very, very specific composition of our environment. So here's the thing. Now, this doesn't really pertain to us in our lifetime, but maybe perhaps somebody in the future, if they're still even watching Spectre Academy, hopefully, this is, something that might affect where, if you're on, let's say, Mars, what is the environment going to be like, and how is sound going to change on Mars, okay? Or on the moon or anywhere else, right? So our environment here is built out of nitrogen, oxygen, and argon, okay? So about 80%, 20, and 1%, and there's like, a little wiggle room in there. So these molecules really, and of course, these are baryonic matter, right? Nitrogen, oxygen, argon, these elements, they are baryonic matter. Okay, so they're 10 billionth of a meter in size and act as the elastic medium for sound to travel here on Earth. Now, actually, if you're curious about this, NASA does actually have recordings of what Mars sounds like. And when you listen to them, they are much darker. And the reason for that is because on Earth, we actually measure our atmosphere in a unit called pascals, okay? And that was Blaise Pascal. He was a Frenchman who discovered basically the unit of pressure. He invented the hydraulic press and all this kind of stuff, okay? So Pascal, that concept of being able to measure how much pressure that you're applying, we use that to see just how heavy our atmosphere actually retains here on Earth, right? And that's all, preserved by the atmosphere and the amount of gravity that we have and all that stuff. There's all of these variables put together. But when you go to a place like Mars, which has much weaker of an atmosphere, you find out that, what was on Earth, which I believe is like 132,500 pascals, something like that, right? It's so much more pressure on Earth. And then when you go to Mars, it's like literally, I'm not even joking, it's like 612 pascals or something like that. Very, very small amount of pressure. There isn't a lot that's keeping those molecules together. Now let's come back to this idea of pressure on Earth, for example. One of the reasons why this is really, really important, or to understand why this is really important, is that let's talk about high frequencies, for example. When you sit, right, when you sit in your sweet spot between your speakers, that high frequency information that's coming from your speakers to your ears, okay, that is all dependent on that environment. And of course, let's think about it this. When you move, a little bit out of that sweet spot, right, it's going to, have a deficiency in high frequency information, right? Because high frequencies are so small. They're so small, which means they're very weak, right? Because in order to get that really, really, really tiny little wave, coming all the way to your ears, well, you need to be able to, not move. You got to stay static. You got to be able to, just receive that information and not have anything obstruct it. Now, let's go back to Mars, for example. Now, Mars, with all this room for molecules to move around, because literally it's not jam-packed at all, right? We're talking about pressure. There's not as much pressure on Mars, which means those molecules literally have more room around them to move, which means it's going to take more energy for that information to hit another molecule to come over to you, because it has to travel a longer distance, okay? So those high frequencies, they darken to us as our tonality. We listen to an environment, something like that, and it's like, whoa, this is not what I was expecting to hear, right? So that's how important this stuff is, okay? Now, again, this is just not because you're going to go and mix on Mars. Nobody's going to do that. Maybe in 100 years or so. But I'm talking about you truly understanding how sound moves, so that when you place your speakers, you have this in mind, okay? Okay, let's keep going. So there are two parts. And by the way, guys, if you have any questions, feel free to put them in the chat. I am more than willing to answer these questions for you. We're going to go on for another 20-ish minutes until this live stream is over. So we have about 2 parts to the sound experience here. We got the physical phenomenon that we can observe, okay? We got particle displacement, which is the kinetic energy we've been talking about. And it's also a measurable science, quite literally. We can literally measure this stuff. And we also have something is a little bit more elusive about sound, which is the psychophysical perception, okay? That we feel, not just physically feel, but emotionally feel, and how those receptors in our brain respond to sound. Okay, this is where your production mindset starts coming into play, more so than just your musical composition mindset, right? Because when you're creating a song, right, you're thinking about the emotional feel in many ways. But then when you're thinking about in a production standpoint, it's how do you translate that emotion to sound so that the other person, it can translate that emotion to them, right? Very, very hard to do, but that's why we're here, right? So our ears, they translate physical sound to the brain, which we'll talk about. And if you have Metal Studio Designer, you can see that part of the course right there. But psychoacoustics, how the brain perceives sound, which is an emotion-inducing kind of power, okay, very important, that we can influence as a producer. Okay, so sound being the result of vibrations. Okay, we call these oscillations. Okay, anything that is an oscillator just means that it generates a sound. Doesn't have to be a sine wave, doesn't have to be pink noise. An oscillator can be your voice, an oscillator can be a piano, it could be a guitar, it could be anything. Anything that vibrates and creates sound. Okay, and we're not going to get too heavy into this, but over the course of history, when it comes to music, okay, guys like John Cage, if any of you ever heard of John Cage in the 1940s, okay, he was an 8-tonal composer who essentially changed how we view using sound for music. Okay, even though John Cage was totally controversial with the way he did it. Okay, he literally had pieces that I think it was like 4 minutes and 13 seconds or 33 seconds, literally just sitting at a piano, and there was nothing. Okay, so there are some controversial things about John Cage, but he made us start thinking about what else could be used for music, even if it was just 2 banging pots. Like, could we use that in music? And yes, we can. It's all about creativity and production. Okay, so oscillations create variations in pressure, okay? And those can be observed through the technology that we call audio, okay? So audio is recorded, transmitted, or reproduced sound, period. End of story. Sound is a form of energy. Audio is analyzing that kind of energy, okay? Or archiving that kind of energy. And in air, those variations in pressure are transmitted through the air known as sound waves, much like waves that are thrown into a pond with a rock. So those kinds of things that you'll see, which water is a very good base for explaining sound, because when you see sound through water or just vibrations through water that just create waves, it visually helps us to understand how sound is also moving in our environment, okay? Now, a wave refers to really any type of oscillation that also transfers energy. So an oscillation of vibration in a repetitive motion back and forth around a point of equilibrium. Let's define that for a second, okay? So equilibrium, what is that? It just really means what's the balance, right? Where is the middle point before positive and negative ever occur, okay? Now, if we think about this for a second, right, our equilibrium, right, where is that? It's here on Earth, right? So the nitrogen, oxygen, and argon that's living in our atmosphere help us, okay, to have this foundation to listen to what disturbances evoke that environment to, have sound. Okay? Because that's what it is. Sound is just a change in air pressure. Okay? Now, acoustic waves, they're going to describe pressure changes that travel through air, liquids or solids. And as the sound travels through the air, the molecules of air are pushed together or they're pulled apart. They create alternating high and low pressure. Now, the high pressure, also known as compression, would be caused by the outward motion of a vibrating body, and low pressure, or also known as rarefaction, okay, is caused by the rarefying motion of a vibrating body, which means the empty space between compression waves. So if you're thinking about, again, just sound, if I'm just doing this to the camera, right, going in and out, when I go towards you, right, I am pushing all these air molecules together, right? Look at it, think of it literally as in water. Put your hand in water and then push the water, right? That's a compression wave right there, right? Because when you do that, what do? You create literally a wave, and all that water gathers up in the palm of your hands as you're pushing it, and then it goes out, right? Then what's rarefaction? You take your hands back, ready for another pull, right? And by doing that, right, even some water splashes back towards your body, right, which goes back to the source, and then it also pushes out more. Okay, so again, this is that whole opposite, forces create an equal reaction concept. Okay, so now there's higher and lower pressure points, okay, which positive for compression, negative for rarefaction. All right, these cause our eardrums to vibrate accordingly, and they fire off nerve impulses that send electrochemical signals to the brain, creating that perception, okay? So there's multiple things that happen in the ear, and it goes, as sound funnels in, that physical air molecule, it moves our eardrum. That eardrum is connected to a couple of bones. They're called ossicles, and they vibrate according to how the eardrum is vibrating into something called the cochlea. And that cochlea has this fluid that we're talking about, this electrochemical fluid, okay, which helps to generate waves inside the cochlea, and then it responds to the nervous system through that fluid into our hair follicle cells there, okay? And that's how it works. So this is an image, just so you can kind of see, right? Even if I had a tuning fork and I hit it and you were to hear the tone, that vibration that's coming out is creating compression and rarefaction, and you can see the wave over here, the C, compression, the rarefaction, the R. Now there are two kinds of waves, actually. It's not just one kind of wave that we deal with. These are actually in acoustics and electromagnetism as well, but the ones that you'll see mostly are compression waves. What you're looking at over here, though, are also transverse waves, which you can see in things like earthquakes and oceans and stuff like that, but we also see it in electromagnetism with transverse waves. Longitudinal compression waves are what we actually experience in the acoustic environment with sound, okay? So primary waves from, let's say, like an earthquake, and shear waves are two different types of versions of a wave that one is a little bit more destructive than the other, okay? So compression waves for an earthquake would quite simply be the first wave that you feel, because compression waves, all they're doing is that kinetic energy that's just transferring information. However, that information does not surface necessarily to the top, okay, which is where, of course, we have our buildings and our cars and stuff like that, okay? So it's just like a little pulse, and it rocks throughout the earth, and it goes very, very far. What comes after that is the shear wave. And the shear wave is the actual wave that surfaces at the top, and it causes the destruction, okay? And we're going to see that look in just a second. But a state of equilibrium you can see over here, and then that longitudinal disturbance are variations of how we, you can sort of see what's in there. But notice, right, it doesn't change what's on top or even below. It's all inside, right? So if, for example, you were in water, right, and all of a sudden an earthquake hit, well, that tsunami that's going to be coming, right, you would definitely feel it when you're at the top, seeing that wave come and hit you. But if you're in the water, you wouldn't necessarily, have the same experience as if you were on the surface, okay? And that inside the water, you would probably hear the earthquake, from such a long distance. And you would hear it much sooner than that tsunami would ever hit those shores. Kind of amazing how this works. So check it out. This is what it's like. So you can see that within the box, right, that longitudinal wave, this compression wave, this is all inside, right? So the displacement is all inside the box. Nothing actually exits the box. But when you're talking about transversal waves, yes, they do. They completely, expand outside of the realms there. And that's the destructive wave here. Just a little visual cue. Let's see how we're doing here. Okay, got about almost a little under 10 minutes. So the nature of electromagnetism is a way that we exhibit all this transversal wave property. So, this quote unquote destructive wave property is actually very useful in the field of electricity. Mainly because look at what you're seeing right over here, right? This is actually a transversal wave, okay? It has a positive and a negative. It is not contained, okay? It has a varying amount of influence depending on the source of the signal. And what you're seeing is not only that you see the electrical, which is, let's just call it the red one, okay? But you also see magnetism flow in sync with electricity. So this is the perpendicular one, the blue one, right, that you see next to it. Electromagnetism as a force, okay? They are closely intertwined with each other. You cannot have one without the other, essentially, okay? So, yes, Nikola Tesla, genius in his own right, was totally onto something when he was trying to build wireless power. And, of course, that's one of the reasons why Nikola Tesla isn't here today, okay? Aside from the fact that this was a very long time ago. But, this is, imagine wireless power, not needing cables really anywhere, right? Only using magnetism to inspire the electricity that's in your devices to actually take effect. Isn't that crazy? Man, I mean, one day we'll live in an age of magnetism, I believe, that we'll be able to control where our things are in our living room just by the sheer amount of, how much magnetic force do we want to move this furniture to this side, or flying cars. That's all going to be about magnetism. Absolutely. Absolutely. We already have some of that technology underway. It's called superconductors. If you want to take a look at that information, it's very interesting. But yes. Okay, so this is the end of the slide for the presentation today. I'm going to go back over here to our other page here because let's check out a little bit of Spectre Academy just for you guys so that you can kind of see what's going on here, okay? This is a very, very, very new way of going about education. Okay? Like I'm not even stressing this, okay? Because never before have we really seen like a platform get this organized, okay? To not only have one-off courses that you can, absolutely totally like learn from on your own time, but also have a dedicated live stream to keep you learning and asking questions like you would be in an actual classroom. And we're not going to just, show off any just mixing, like this is all aspects of our industry. We're going to have things like music business. We're going to have things like, of course, audio production. We're going to have music performance and technique. We've got all these different types of people that are a part of this. I mean, let's just take a look at some of the courses that you'll get over here. You know, if you go to Spectre Academy, these are, and a lot of these you'll see now, if you're familiar, of course, with Metal Mastermind's very own course platforms. We have all of our courses here on Spectre Academy now, and you can see here the slow-mo suite, killer scale runs, etudes for electric guitar, and sweep picking master are all made by our guitar virtuoso, Alfred Potter, amazing instructor. He's got this really, really soft tone that's just kind of like meditative. You know, so I gotta hand it to Alfred. He's really good at this stuff. We also have a brand new instructor on the Metal Mastermind team. His name is Todd Burke. Some of you may know of Todd Burke. If you don't, Todd's a legendary recording and mixing engineer. He's worked on Gary Jules, Donnie Darko. I mean, he's done like he did the song Mad World. You know, so like this is some really exciting stuff. This particular course, the fundamentals of recording, is an amazing course. And by the way, again, you get all of this in your all access pass subscription, right? So where we had actually with the Inner Circle, we were charging, I think, upwards of $50. We're down to $40 to give you guys more access on this kind of stuff with Spectre Academy. So this is like a really, really exciting time for Metal Mastermind, and I hope you're just as excited to learn from some of this stuff. And we're running a promo right now that's $1 to get started. After your first 2 weeks, then you get charged for whatever it is that you selected, whether it was monthly, quarterly, or annually. Okay. So really, there's no risk involved. I mean, we have a 14-day policy that if you don't like what you got, we'll refund that for you for the first month. The Metal Vocal Virtuoso, Metal Bass Master, Metal Studio Designer, Metal Producer Overload. These are all Metal Mastermind courses that are available here now on Spectrum. Okay, so let's take a look at some of the other ones that we got going on here. By the way, we have some new courses that are up and coming. We have been working on them, oh man, since like maybe like December of last year. I got some really good ones that are coming up. We're going to talk about like analog consoles, Dolby Atmos. I've got we have a War Machine merch with Ro Coley. He's working with us too. So we've got a merchandise course that's going to come and help give you guys the information of what you actually need. You're learning from the best, okay? Ro Coley has been doing work for so many brands and metal projects. I mean, he was I didn't even know that Ro Coley was the merch guy for the Resident Evil series back when it first launched with Capcom. So I mean, like, this is like the kind of people that we're putting here with Metal Mastermind for you guys, okay? And Ro Coley's an amazing instructor. We got Metal Songwriters Forge. Many of you are familiar with that. We got Metal Music Theory, of course. You've got those are staples. And then, we got a couple of things over here as well. Creative Guide to AI Music Production with Henning Pauly. Henning Pauly is an amazing YouTuber. He also creates so many courses on this platform, especially for songwriting. These are things that I honestly think are such a great pairing because, not only do you guys get, Metal Songwriters Forge, which is, of course, a Metal Mastermind course, but you also get access to all of other Spectre's courses on All Access. So you can learn from me, you can learn from, Alfred, but you can also learn from Henning, and you can also learn from Ty and David Velez and all these things that are really, really useful here, okay? So Spencer Sotelo from Periphery and all that, and Alex Nasla. These are fantastic courses that are going to give you a lot of juice and information, okay? Let's keep going. We also still got Glenn Fricker. Okay, so Glenn, some of you already know or may have not heard, but Glenn Fricker actually left Spectre Digital. Glenn is doing his own thing. God bless him. But Glenn still has his courses here on Spectre Academy. So if you ever want to learn from Glenn, these courses are not leaving the platform. They're staying here on the platform, and you're going to be able to continue learning. And Glenn can also, if he wants to conduct a live stream, he's more than able able to do that on Spectre Academy as well at any capacity. Okay, so we've got more stuff here, you know, SMG Savage Grooves, or the Blues course if you want to dive into a little bit of, you know, expanding your palette, which is such an amazing thing to see here. And of course, there's more coming, guys. This is, you know, about, I think, 40 plus courses that we're working with here, and more's coming down the road. Okay, so this is exciting times. I'm really, really happy to be here with you guys. Please definitely check this out. The All Access Pass. This, like I said, the first live stream is here. We're hosting a hit on Metal Mastermind today. But, you know, in the future, it will be hosted on the Spectre Academy's account. And also it will be on Zoom. So you'll actually get, you know, one-on-one interaction. It's not just going to be a chat bubble over here, but you'll actually be able to talk on Zoom. We're still figuring out the details. We actually conducted this live stream for 2 reasons. One, for testing, and then two, to also help get the word out. So that's it for today, folks. You know, thank you so much for your time. I'll stick around for maybe another minute or so, and if you have any questions, I am more than happy to answer them. All right.